everyone, welcome to APS Deep Academy and this is your mentor Swati Joshi. In this class, we will study about PN junction diodes. In last class, we already know about PN junction and formation of depletion layer and forward and reverse biasing. Now, in this class, we will study PN junction diode. Now, a diode is a two-terminal device which can conduct or start flow in one direction, which is in forward. So, the current always flow in one direction. Now this is our cathode terminal, which is negative. This side is negative and cathode, and this side is positive, which is anode. And this is our forward current, which only flow when we bias the diode for forward bias. Now what happened? If I talk this diode as a circuit element, then in circuit what we have two kinds of things. One is the ideal circuit condition and the second one is practical condition. Now, what is ideal condition? In ideal condition, we have some parameters. So we can consider that this circuit is ideal, and we are creating or solving this for to create a reference level or reference levels. So, and a practical circuit is one which we perform in our electronic labs. So, practical circuit are basic one which are realistic. Ideal circuits are not realistic, but we need ideal circuits. So we can consider start a parameter regulation. So these are the parameters, so we have to consider this, and according to this the changes will be this. Similarly, if I have to study the PN junction circuitry, then we have to know that what are the ideal and practical condition of a PN junction diode. Now let us begin with the ideal condition. So what has happened in ideal condition? Let's say if this is a diode and this is an ideal condition, we know that in forward bias it will start conducting. So forward bias, we know that we connect P side to positive terminal and N side to the negative terminal. So this is the condition. So what happened in forward bias condition of an ideal diode? We consider that it possesses a zero resistance here. It means the terminal resistance of this device or this diode is zero here. So what is happening here? If the resistance is zero, it means the current will flow infinitely in this circuit. Okay. If this current is infinite, then we consider those circuits as short circuit condition. So in ideal diode condition, if the circuit is forward biased, then we consider it as short circuit. Now, what a short circuit means? A short circuit always resistance, internal resistance of the circuit is zero and the current flowing through it is infinite. So, this is the condition of a short circuit. Now, if I consider this as a mechanical switch, then the switch is closed. Okay. This is the case of ideal forward bias diode condition. Now, if I talk about the reverse bias condition. So, what happened in reverse bias? Let's draw one more diagram here. In reverse bias, we know that in reverse bias, we connect this P side to negative terminal of the battery and this N side to positive terminal of the battery. So, this is the condition of reverse bias. So, in reverse bias, what is happening in ideal diode, the resistance of the circuit is infinite. Why so? Because reverse bias is also acting as blocking bias. Blocking bias means it is opposing the current, so resistance will be infinity. And if resistance will be infinity, so current will be almost zero. No current will flow in this circuit. So, as a part of discussion, we will consider this circuit as an open circuit or an open switch. Open switch condition. If this is a mechanical switch, then it is open all the time in the case of reverse bias ideal diode condition. Okay, now here are two things we have to consider, R and I. In open circuit condition of reverse bias PN junction diodes, the resistance is infinite and current is zero, whereas in short circuit condition of ideal diode forward bias, the resistance is zero and the current is infinite. Now let us discuss this in detail with the help of VI characteristics. Ideal diode. VI characteristics. Okay. Now in horizontal axis voltage is there vertical axis current is there. Similarly, this is for reverse bias and this is for forward bias. Now what is happening here? We know that resistance is 0, so current will be infinite, R equal to 0 we consider, and in reverse bias I equal to 0 and R equal to infinite. Okay, so this is the condition of open circuit and this is the condition of short circuit. Now why we study those ideal diode, or why you have to know that? Because sometime in numerical what happened, the questioner asked that condition, it is condition apply only for ideal diode, or somewhere it is written that okay, this is only for ideal diode. In this case what you have to follow the parameters of ideal diode. Now here, what are the fundamental parameters? Okay, you consider R equal to 0, I equal to infinite. What will be the V? We know that V is equal to IR. So if V is equal to IR, I equal to 0, so V is also equal to 0. So this is the case of ideal diode. Similarly, we can do for reverse biasing also. So what is happening here? Here, few parameters are written in ideal condition which we can use to perform our numerical practices or creating the reference level. So this is the basic VI characteristics of ideal diodes. In next class, we will study practical diodes and their VI characteristics in detail. Thank you so much.